So welcome to lesson 2 of polynomial functions and equations. We actually get to go back to grade 6 and do long division today, which sounds absolutely amazing. But when we were in grade 6, we probably kind of hated it. Long division arrives at us through polynomials, but we're going to have to review it using regular numbers. The first example shows a trinomial being divided by a monomial. And that monomial actually can be applied separately so that I can more clearly see what the result is. Every part of the numerator has to get divided by 5x, and I can do that division quite nicely. 15x cubed divided by 5x is 3x squared. 10x squared divided by 5x is 2x. The minus sign keeps following me around. And 5x divided by 5x is 1. That 1 is still there. So there's some language associated with division. The divisor, the quotient, the remainder, and the dividend. I'm trying to divide into 20. That's the dividend. Sorry, I was having trouble with my orientation, but that's fixed. We have some language to get used to. The dividend is what you're dividing into. So the dividend in 20 divided by 3, the dividend is 20, and you're dividing by 3, that's the divisor. So 20 divided by 3. The quotient is 6, because 20 divided by 3 is at least 6, and the remainder is 2. So continuing forward, so the idea of working backwards would be to be able to rebuild the dividend. So how do you rebuild the dividend? You can see that the dividend can be rebuilt by taking the quotient, by taking the divisor and the quotient and multiplying them together and adding the remainder. That'll work. Or you can rewrite the result of your division in an other format by writing the dividend divided by the divisor and write it as the quotient plus the remainder divided by the divisor. I'm going to try reorienting again. One moment. The language that we're going to have with polynomials is that we're going to start with a polynomial that we're going to have a divisor for. So the divisor times the quotient will plus the remainder will be equal to the polynomial, or an equivalent statement would be to write the polynomial divided by the divisor is equal to the quotient plus the remainder divided by the divisor. Again, language here we need to practice. So some of you did some long division practice yesterday already. I have to long divide 25 into 5,773. And remember, maybe you remember how that goes. Does 25 go into 5? No, 25 goes into 57. How many times? Twice. 2 times 25 is 50, and I have to subtract that. And then bring down the 7. And now I ask myself the same question. How many times does 25 go into 77? Well, that's 3 times. 3 times 25 is 75. And I do another subtraction. I'm left with a 2. Bring down the 3. And it turns out that 25 doesn't go into 23 anymore. So this can be written as 5,773 divided by 25 is equal to 23 plus my 23 that still has to get divided by 25. So we're going to practice some long division with monomials and binomials. It's been started for us, trying the same language. They did this already. X times x was x squared, and that was left with nothing there. I have to bring down the 3x. Then I ask myself, something times x is 3x. That's a 3. 3 times x is 3x. And I was trying to fix my orientation. So that was a 3 sitting there. 3x times x is 3x. I have to subtract that. That's left with 0. I bring down the 18. Now x doesn't go into 18. So the best I can do is write this as the final result, or in the form that they've asked for, sorry, in this form. The polynomial would be the result of x times x plus 3, and to that I still have to add 18. Now I have a trinomial, and actually the trinomial had some missing terms. You'll notice that a 0x squared has been introduced. That's going to be significant in the processes that we have to do. And I'm dividing by x again. So x squared times x is x cubed. Subtracting that left me with 0. I don't need an x squared term. So 0x times x is 0x squared. That 0 is going to eventually disappear. I have to focus on my 5. Something up here, negative 5. Negative 5 times x is minus 5x. I have to subtract that. Negative 5 minus minus 5 is 0x. And then bring down the 6 from all the way up there. 6 doesn't go into x. So this polynomial can be written as x times x squared minus 5, and to that I still have to add 6. The next one gets a little more interesting, an actual trinomial, 3 terms with all the exponents present. Why was the 2x there first? The 2x was there first because 2x times x is 2x squared, 2x times 2 is 4x. And now I have to be careful with my work. I have to remember that it's subtraction. 2x squared minus 2x squared is 0x squared. Negative x minus 4x is minus 5x. And then I bring down that next term, which is a minus 18. And now I ask myself the question, what do I need in the quotient portion? So something times x is 5x. That's minus 5. Minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. I need to remember I have to subtract that. Negative 5 minus minus 5, that's 0x. That's what I want to have happened. And negative 18 minus minus 10 is minus 8. So this polynomial can be expressed as x plus 2 times 2x minus 5 with the remainder of minus 8. So we have 2 big examples to do. I have to set this one up. It's going to look very similar to the one that I just divided, but I have to write it in the alternative form. Notice that I want it in the form of polynomial divided by divisor is equal to quotient plus remainder divided by divisor. I'm going to set it up first. So I've given myself all the descending powers of y cubed, 0y squared, I've got a 6y, and I've got a 20. My attention is always on the first term. So something times y is y cubed, that's y squared. And y squared times minus 3y is minus 3y squared. I have to subtract, making sure to watch signs. So y cubed minus y cubed, that's gone. But 0 minus minus gives me 3y squared. Bring down the 6y. And then ask myself, what's the next number? Well, I need a plus 3y. Plus 3y times y is 3y squared. And 3y times minus 3 is minus 9y. Again, watching my subtraction, 3y minus 3y is 0. Minus 6 minus minus 9 is a plus 3y, and then plus 20. I've got to make my paper a little bit longer. So now a 3y needs to be generated. That's a plus 3 up there. I'll change color for you. So 3 times y is 3y. I didn't like to go longer on my orientation. 3 times y is 3y, and 3 times minus 3 is minus 9. And now I have to subtract. That first term always gets to 0, and 20 minus 9 is 20 plus 9. So I have a remainder of 29. So written in the form that I've been asked to, y cubed minus 6y plus 20 over y minus 3 is equal to my quotient, which was y squared plus 3y plus 3. And then I still have to take that 29 and divide it by whatever y minus 3 is, which at this point I don't know. That's it for this one. Let's turn the page. So we have some language that we're being introduced to. When a polynomial is divided by a polynomial, px and dx respectively, we're going to get a quotient and an R statement, a polynomial statement that meet the following criteria. If the remainder is equal to 0, then dx and qx are both factors of p at x. That's going to be something that we rely on. If the remainder statement is not equal to 0, then d at x and q at x are not factors. And there's a relationship between the degree. You'll see it after you do a number of them. The degree of the divisor must not be greater than the degree of the polynomial, and the degree of the remainder must be less than the degree of the divisor. I've got to set up this one, and then we'll long divide. I finally got it at a spot that I can write. I'm going to try to attempt to long divide. First, I'll write it out, and then I'll talk it through. I sort of got the orientation to work. So my long division is off to the right here a little bit. I've long divided 2x minus 1 into the dividend, which was kind of big. My first focus was on the 6x to the 4, and I put a 3x cubed on top, because 3x cubed times 2x is 6x to the 4. And then the 3x times minus 1 is minus 3x cubed. I've got to subtract that, so I've got to watch my signs. The first terms go away, 6x to the 4 minus 6x to the 4. But the 5x cubed minus 3x cubed is 8x cubed. Then I had to bring down the 0x squared, my placeholder. And now my focus is what times 2x is 8x cubed. And that's the 4x squared. 4x squared times 2x is 8x cubed. And then 4x squared times minus 1 is minus 4x squared. Again, I have to subtract. The first terms go away, watching my signs. And then that continued for 2 more steps. And I end up with no remainder. By the time I get to the bottom carrying out those same steps, I end up with no remainder. So this is one of my first times where, yes, 2x minus 1 is actually a factor of my dividend because it goes in evenly. I'm going to stop the recording there. My orientation has been horrible. I hope the lesson goes well tomorrow. Long division is fun, but it needs a shortcut, which will come in the next class. Thank you.